Alright, hello guys. In this video, we are going to talk about the inverse variation, which is our worksheet 9.2A. So if we have the y is inversely proportional to x, so which means that we can change the inversely to become directly, and we can change the x to become 1 over x, so we can using our technique to change the whole thing to become y is directly proportional to 1 over x. So every time you see this fishing sign, we can change it to y equal to k times 1 over x. So that's the meaning of inverse variation. So let's move to our first example. As we can see here, y is varies inversely as x squared. Then we can change the inversely to become directly, and then we can change x squared to become 1 over x squared. So we can write something like y is proportional to 1 over x squared. And then we can change it to an equation to change the proportional sign to become equal to k. Then we have y is equal to k over x squared. And as we stated in the questions, the condition is when x is equal to -4, we have the y is equal to 3 over 8. So then we can substitute the x equal to -4 into here, and we substitute our y equal to 3 over 8 into here. Then we can have the y is equal to 3 over 8, then it's equal to k over -4 squared. So -4 squared will give you a 16, which means that 3 over 8 is equal to k over 16. And then we move the over by 16 to the left-hand side, and we can have the k is equal to 16 times 3 over 8, and this will give you 6. So 6 is our variation constant. But please be remembered that 6 is now our final answer, because the question is asking about to connecting x and y. So next step, we need to put back this k equal to 6 back to this original formula. Then we can have so that the y is equal to 6 over x squared. So this is our final answer for part A. So let's move into part B. The part B is asking the value when x is equal to the half. So which means that when x is equal to half, what's the value of y? So basically we can just substitute our x is equal to half back to this formula. Then we can have the value of y is equal to 6 divided by half squared. So a half squared gives you a quarter, which means that can change it back to 6 times 4 will give you a 24. So the answer for y should be 24. Okay, so now moving to question 2. So in question 2, we are given a relationship between v and h. So v is directly proportional to 1 over the square root h. So for this one, we can just write it as v is proportional to 1 over square root h, which means that we have v is equal to k over the square root h. As we have the relation, we have the condition that the h is equal to 16, v is equal to -3. We can substitute the value inside our equation. Then we can have, so we substitute h equal to 16, v equal to -3 into this formula. Then we can have -3 is equal to k divided by the square root of 16. So next step, we can calculate out what's the value of square root 16, which will give you a 4. So k will be equal to the -3 times a 4, give you a -12. As again, the k is our variation constant. It's the variation constant. It's not the final answer here, as the question is asking you to express v in terms of h. So now we need to put back the value of k, which is -12, back to our original equation. Then we can get our answer. V is equal to the -12 divided by the square root of h. So this is our final formula. So for question B, they're asking to find out the value when v is equal to -4 divided by 5. So we are given that. So given that the v value is equal to -4 over 5, to find out the value of h. So now we can substitute this v equal to negative 4 over 5 into this equation, then we can have negative 4 over 5 is equal to negative 12 divided by the square root h. Then if we rearrange it, then we can have the square root h is going to be equal to 12 times 5 divided by 4. Then we have this is equal to 15. So that's the h is equal to 15 squared. A lot of people make mistake here. So be careful when you don't want the square roots. You're giving the square to both sides. So we have the 15 squared is equal to 225. So that's the solution for question 2. Alright, now moving to question 3. I'll only do question 3. So because, be careful, they said the y plus 3 is inversely proportional to the x to the power of 4. So we write it down first. We have y plus 3 is inversely proportional to x to the power of 4, which means that we can change the inversely to become directly. And we change the x to the power of 4 to become 1 over x to the power of 4, which means that we can write it the rest. Y plus 3 is directly proportional to 1 over x to the power of 4. And that's why I said before, the fishing sign can be changed to equal to k, so that we have y plus 3 is equal to k times 1 over x to the power of 4. And now we have the condition that is x is equal to negative 1 and then the y is equal to 21. So we can substitute. X is equal to negative 1, y is equal to 21 into our formula. Then we can have 21 plus 3. Don't miss out this 3 because the question giving you this 3, so you must use it. So 21 plus 3 is equal to k divided by x to the power of 4 when x is negative 1 to the power of 4. So be careful, somebody make this mistake. So negative 4 to the power of 4 is not equal to negative 1 times 4. It's the meaning of minus 1 times minus 1 times minus 1 times minus 1 again. So 4 negative times together will finally give you a positive 1. Okay, so that we have, this is 24 on the left hand side is equal to k divided by 1. Then we have our variation constant, k is equal to 24. So now this is not our final answer, as the question is not asking for the variation constant. What we need is to express the y in terms of the x. So now we need to put back our k. We need to put our k back to this formula. Then we can have our formula is y plus 3 is equal to 24 divided by x to the power of 4. Then we rearrange the plus 3 to the right hand side. Then we have y is equal to 24 over x to the power of 4 minus 3. So that's our final relations between the y and x. So that's for question A. And now moving to question B, we have to find out the value of y when x is equal to the square root of 3. So now we are giving, as we are giving the value of x is equal to square root 3, to find out the value of y. So we just need to substitute the x value into the formula. So substitute this negative square root 3 into here. Then we can have our y is equal to 24 divided by the square root 3 of 4 to the power of 4 and then minus 3. So square root 3 to the power of 4 is basically equal to square root 3 squared and then squared again, which give you 3 squared, give you 9. Alright, so this will give you y equal to 24 over 9 minus 3. So the final answer should be equal to 24 over 9 minus 27 over 9 should be equal to minus a third. So that's our final answer for question 3. So now we're moving to our fourth questions. So this question is a little bit tricky because this is a wording questions and there's some tricky place we need to be clear about. So they said Patrick bought a new car. So Patrick bought a new car at the end of 2012. The value P of the car varies inversely as the number of the year he bought. So if the value of the car was 60k at the end of 2015, so we need to find out the value of the car at the end of 2016. So first of all, we need to be clear about what's the meaning of n, so the number of years that he bought. So first of all, we have this timeline when this is the end of 2012. Then how many years has already passed at the end of the 2015? Because this is 12, the first year passed. This is the first year we passed going to the 13. We passed another year going to the 14. We passed one more year going to the 15. So when n is equal to 3, it's going to be at the end of 2015. And similarly, we have at the end of the 16 is actually the 4th year. So when the n is equal to 4, which means it's at the end of 2016. So first of all, we can have this relationship that P is varies inversely as the number of year that he bought. So we can say that the P is varies inversely as the 1 over n, which means that we can write as P is equal to K over n, right? So the condition that we have is at the end of 2015, the value of the car, which is the P, is 66,000. So we can write down the condition. We're given that at n equal to 3, the P is equal to 66,000. Then we can substitute these two values back to our formula. Then we can have the 66,000 is equal to K divided by 3, which gives you the value of K is equal to 198,000. And after that, we need to find out the value at the end of the 2016. So first of all, we need to find out the formula connecting P and N. So we substitute this variation constant back to this equation. Then we can find out the P is related with 198,000 divided by n. So that's our formula. So after substituting, so at the end of 2016 means that n is equal to 4. So we can substituting n equal to 4 back to our equation, so that the P at 2016 is going to be equal to 198,000 divided by 4. So give you the final answer should be 49,500. So it's a little bit tricky part because you need to change the end of the 2015 back to our values in terms of n, which is give you n is equal to 3. And you need to realize that at the end of the 2016 will give you the n value of 4. So this is the solution of question 4. So let's move to our last question 5. So it's a little bit hard question, but it's not undoable. I think some of the students can do it, I think just 1 or 2, but try to do it as well. It's quite easy to understand actually. So first of all, we got these relations. We do the similar stuff, so we can change our variation sign to become the equal to k. Then we have the z squared minus 4 is equal to k times 1 over x plus 3. X plus a, sorry. So because we have two variation constant here, so we have k, we have a. So the question gives us the two conditions. So the first conditions, so we have the first condition, which is when x is equal to 5, the z is equal to the square root of 5, so that we do the similar thing. We put in our x and z value into our formula, and let's see what's happened. So when we substitute z is equal to square root of 5 to the formula, we got the square root of 5 squared minus 4 is equal to times the k times 1 over 5 plus a. As the value of k and a are something that we need to find, so we keep the value of k, we just change c to become square root of 5, and we change x to become the 5. And we do something about this formula, then we can get the square root of 5 of the square root of 5 squared give you a 5, 5 minus 4 will give you a 1. So 1 is equal to k over 5 plus a, then give you that the k is equal to 5 plus a. So this is our first equation. And the second condition is that when the x is equal to 7, z is equal to the square root 43 divided by 3. So z this time is a little bit ugly, but we can still do it. Just do them step by step, okay? So we substitute z to the formula, then we have the square root 43 divided by 3 squared minus 4 is equal to k times 1 over x is 7 plus the a. So be careful about this part. I will do it separately. So square root 43 divided by 3 squared is actually equal to 43 divided by 3 squared will give you a 43 divided by 9. Alright, so 43 divided by 9 is the value of here, and we need to minus a 4, so we give you a 43 divided by 9 minus the 36 divided by 9 again, and then we can substitute our k value, which found it in the first condition, 5 plus a, so we have a 5 plus a divided by a 7 plus a. And if we simplify a little bit, then we can have 7 over 9 is equal to 5 plus a divided by 7 plus a. And after that, we can cross times them, times the numerator and denominator together. Then we can have something like 7 times 7 plus a is equal to the 9 times 5 plus a. After that, we expand the bracket, then we can have 49 plus 7a is equal to the 45 plus 9a. So after that, we can move the 7a to the right hand side, then we have 2a is actually equal to 4, which means that a should be 2. So now we find out the value of a, then there is an equation connecting the k and a, which is k is equal to 5 plus a. So that's the k value should be 5 plus 2, giving you a 7. So now we have the value of a and we have the value of k, so that we can put it back to our original formula, this one. This is our original formula with unknown k, unknown a. So now we find it out so that we can put it back to our formula. So that our solution should be z squared minus 4 equal to k should be 7, and then times 1 over x plus 2. And then because they need z in terms of x, so we need to make z become the subject. So which means that we need to do some arrangements. Then we have the z squared is equal to 7 over x plus 2 plus 4. Then we have that z is equal to the plus or minus the square root of the rest. However, as the question stated that x and z should be positive numbers, so in this plus or minus sign, which means that we just only need a positive one. So that's the answer for this question. Thank you. So if you have any question, don't hesitate to ask me via WhatsApp. Okay, thank you.